Here is a puzzle for you. A shopkeeper has 55 liters of oil of one kind, 210 liters of another kind. He wants to sell the oil by filling the two kinds of oils in cans of equal capacity. Can you find what should be the greatest capacity of such a can? Now, let us try to solve it practically. Take two oil cans of capacity 55 and 210 liters. The oil can of 55 liters capacity is filled with one kind of oil. Can you say how many full cans of capacity 55 liters are required to fill the can of capacity 210 liters? To find this, we pour full can of 55 liters into the 210 liters cans and count the number of cans required to fill it. Here, 3 full cans of 55 liters are required, but a portion of 45 liters of the bigger can remains unfilled as we cannot pour a full can. So, the capacity of the bigger can be expressed using a relation 210 is equal to 3 into 55 plus 45. Let us consider this as equation 1. We observed that the cans could not be filled completely, so we take another set of cans, the smaller of the previous cans, that is 55 and the remaining 45. Here we observe that one full can of 45 liters can be poured into the 55 liters can. The remaining portion of 10 liters is left out as we could not pour a full 45 liters can. This can be expressed using the relation 55 is equal to 1 into 45 plus 10. Let us consider this as equation 2. Since the can could not get completely filled, we take another set of cans, the smaller of the previous cans, that is 45 liter capacity and the remaining 10 liter capacity can. How many full cans of capacity 10 liters are required to fill the can of capacity 45 liters? Pour oil from the smaller filled can to the bigger can. Now, we observe that 4 full cans of 10 liters were poured and 5 liters of the 45 liter can still remains unfilled as we could not pour a full 10 liter can. This can be expressed as 45 is equal to 4 into 10 plus 5. Let us consider this as equation 3. Now, since the can could not get filled completely, we take another set of cans, the smaller of the previous cans, that is 10, and the remaining 5 liter capacity can. How many full cans of capacity 5 liters are required to fill the can of capacity 10 liters? Pour the oil from the smaller filled can into the bigger can. We observe that the can gets completely filled when 2 full cans of 5 liters are poured. This can be expressed using the relation 10 is equal to 2 into 5 plus 0. Let us consider this as equation 4. Now, observe the relations expressed by equations 1, 2, 3 and 4. Thus, we can say that the maximum capacity of the can to get completely filled is 5 liters, which is nothing but the HCF of the numbers 55 and 210. Now, let us solve another problem using the same method. We have already learned to find HCF using the method of prime factorization. Now, let us learn to find HCF using other methods. YB is making a game board for his party that is 18 inches by 48 inches. He wants to use square tiles. What is the largest tile he can use? The solution to the problem can be found by taking the HCF of 48 and 18. When we divide the number 48 by 18, we get a remainder 12. This relation can be expressed as 48 is equal to 2 into 18 plus 12. Similarly, when we divide the number 18 by 12, we get remainder 6. This relation can be expressed as 18 that is equal to 1 into 12 plus 6. Now divide 12 by 6, remainder is 0. The division stops here. This can be expressed using the relation 12 is equal to 2 into 6 plus 0. Thus, the HCF of numbers 48 and 18 is 6. The steps we just followed to calculate the HCF is the Euclid's division algorithm. This algorithm uses Euclid's division lemma, which states that for given positive integers a and b, there exist unique integers q and r, such that a is equal to bq plus r, where r lies between 0 and b. In the above example, we saw the relations expressed using the equations 1, 2, and 3, where each statement is Euclid's lemma, a is equal to bq plus r. We observe that in equation 1, a is equal to 48, b is equal to 18, q is equal to 2, and r is equal to 12. For equation 2, we have a is equal to 18, b is equal to 12, q is equal to 1, and r is equal to 6. Similarly, for equation 3, we have a is equal to 12, b is equal to 6, q is equal to 2, and r is equal to 0. All these equations satisfy Euclid's division algorithm. What is the difference between an algorithm and a lemma? An algorithm is a series of well-defined steps which gives a procedure for solving a type of a problem, whereas a lemma is a proven statement used for proving another statement. Why is this method more preferred when compared to the prime factorization method? This algorithm is a much shorter and faster way to calculate the HCF as compared to factorization method that we saw earlier. Now, let us summarize Euclid's division algorithm. This is based on Euclid's division lemma. According to this, the HCF of any two positive integers a, b, where a is greater than b, is obtained as follows. Step 1. Apply division lemma by dividing the bigger number, dividend, by the smaller number, divisor, to get the quotient q and the remainder r, where a is equal to bq plus r, 0 less than r less than b. Step 2. If remainder is not equal to 0, divide the divisor, which is the new dividend, by the remainder, which becomes the new divisor, to get a new remainder, that is, apply Euclid's lemma to b and r. Step 3. Continue the process of dividing the divisors in succession by the remainder got till we get the remainder 0. Step 4. When the remainder is 0, the HCF is the last divisor of the given two numbers. Now, let us know about Euclid. Euclid was born around 300 BC in Greece. He is also known as Euclid of Alexandria. He was a great mathematician and is often referred to as the father of geometry. His Elements is one of the most influential works in the history of mathematics, serving as a main textbook for teaching mathematics, especially geometry, from the time of its publication until the late 19th or the early 20th century. In the Elements, Euclid deduced the principles of what is now called the Euclidean geometry from a small set of axioms. Euclid also wrote works on perspective, conic sections, spherical geometry, number theory, and rigor. Euclid is the anglicized version of the Greek name meaning good glory. Prove that every positive even integer is of the form 2m and every positive odd integer is of the form 2m plus 1, where m is any integer. Let a be any positive integer and let b is equal to 2. According to Euclid's division lemma, there exist two unique integers m and r such that a is equal to bm plus r, that is equal to 2m plus r, where 0 is less than or equal to r less than 2. Thus, r is equal to 0 or 1. If r is equal to 0, that is if a is equal to 2m, then the expression is divisible by 2. Thus, it is an even number. If r is equal to 1, that is, if a is equal to 2m plus 1, then the expression is not divisible by 2. Thus, it is an odd number. Thus, every positive even integer is of the form 2m and every positive odd integer is of the form 2m plus 1. Now, let us apply Euclid's algorithm to solve a real-life problem. An army contingent of 616 members is to march behind an army band of 16 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns that they can march? Here, Euclid's algorithm is used to find the HCF of 616 and 16. We start by taking the bigger of the two numbers, that is 616 as dividend and the smaller number 16 as divisor to get the remainder. Applying division lemma, we get the relation 616 is equal to 38 into 16 plus 8. Since the remainder is not equal to 0, we consider 16 as the new divisor and 8 as the new dividend. Applying division lemma to the numbers 16 and 8, we get 16 is equal to 2 into 8 plus 0. The remainder has become 0, so the division process stops here. Since the divisor at this stage is 8, the HCF of 616 and 16 is 8. Thus, the maximum number of columns required for the army contingent to march behind the band is 8.